Good morning, and this is the recording for the integrated math on congruence polygons and triangles that we couldn't do because the system was down when we actually did the lesson. So I'm going to go through this and have a recording available for everybody. So our essential questions today is why can't you use SSA or AAA to prove two triangles congruent? And SSA means side-to-side angle, and AAA means angle, angle, angle. So if you need to pause this for a second while you're copying this down in your notes, go ahead and do so and start it when you're ready. So we're going to do a quick review of stuff from the previous week. And one of those review items is that if we have two polygons that are congruent, then we've given us some information. So here's the postulate that helps us know that. So first of all, it says two polygons are congruent if and only if there is a correspondence between their sides and angles, so that all pairs of corresponding sides are congruent and all pairs of corresponding angles are congruent. So remember, congruent means they're going to be exactly the same. So the two angles are going to have the exact same size. The corresponding sides will have the exact same size. Now, I know that they're corresponding sides because of the way they're marked. So see, this one has a single tick mark here, and this side here has a single tick mark. And those tick marks indicate that those two sides are congruent. This one has two tick marks, and this one has two tick marks. The reason we put a second one there is to differentiate between this one and this one, because if there's only a single one here, we would be saying that side's the same length as this side. Okay, so these two sides are the same length. These two sides are the same length because they have three tick marks, and these two sides are the same length because they have four tick marks, and they're different lengths. These two sides are different lengths than either of the other three sides that are there. If it was not different, there's how the same number of tick marks as the other side. Another side that is similar to. Also the same thing with the angles. Notice that this little mark here and this little mark here, that's indicating that those two angles are exactly the same size. And same thing here, that those two angles are congruent. And you can see the three of those there, and those two angles are congruent, and these two angles are congruent. And these angles right here are not congruent to any other angle because this has different numbers of arcs marked on there than the other angles. And that's also, as they were labeled, polygon ABCD is congruent to polygon FGHI. That the A and the F match up here. They're listed in the same order as they are in terms of congruence. So A then goes to B, C, D, and the F matches with the A, the G matches with the B, the H matches with C, and the I matches with the D, and so they're listed in that order here as well. So I know two polygons are congruent from this postulate if and only if there is a correspondence between their sides and angles, so that all pairs of corresponding angles are congruent and all pairs of corresponding sides are congruent. That means this side and this side, all the sides have a pair that make a pair that's congruent, and all the angles match to something the other one and are congruent, and they're in the same locations as the other as well. This one is in the same location as this one, and so on. The other postulate that we need to have in mind today, it says if B is between points A and C, there's A and C and B is between them, on a line, and we know it's a line because it has the arrows on the end, then the segment AB plus the segment BC gives me the segment AC. So here they're not talking about the line parts, they're talking about the segments from A to B and from B to C It gives me the whole thing from A to C. And the other thing you know is that if AB plus BC, as we're trying to do, doing that in order as we label things, equals AC, then we know that B has to be between A and C. So it goes both directions there. The next thing we need to know today as we're working on things is something called the reflexive property of congruence. And basically says any side is congruent to itself, or any angle is congruent to itself. So for example, we have a triangle ABD, and it's congruent to triangle CBD. As far as we can tell, haven't been told that, but we've got that triangle ABD, and actually it's CDB, because you have to have it in the same order as the other one. They share a side. So the side DB they share. And since DB is congruent to BD, it makes sense because it's the same side. DB is the same as BD, it's just that we reverse the order. And remember from earlier, on a line segment you can reverse the order of the letters and it's still the same line segment. So if that DB is part of one triangle and BD is part of another triangle, we can say that the two sides are congruent to each other because they're the exact same side. And that's what the reflexive property is telling us. And sometimes we have to actually state that when we're justifying what we're doing in terms of showing that two triangles are congruent to each other. So kind of thinking about this reflexive property, what postulates can you use to prove that line segment AE, so it's going from here to here, is congruent to line segment DF. So it's going from here to here. And one of the things that I'm noticing is that if I'm drawing line segment AE, and then I draw in line segment DF in a different color, that they're overlapping and sharing something. They're sharing a section there. And so that section that they're sharing, since it's the exact same section, reminds me that probably one of the things I'm going to be using is the reflexive property. So since they're sharing that part, then we can say FE, line segment FE, is congruent to line segment EF. And that's one of the postulates that we can use with reflexive property. The other thing I see is if I ignore the top part, I'm ignoring the top part here. Let's see. So I'm going to kind of block the rest of this out. I see a line segment at the bottom. And so if I go back to the little properties back here, and postulates, excuse me, and then I see this segment addition postulate, and it says, if I take AB to this segment right here, and I add it to this segment right here, I get the entire segment. So, if I have from A to F, or AF, when I add FE, do I get the same thing as DE, and then I add EF? Now before we start, we've got to notice one thing. Notice there's these little tick marks here. Remember I said earlier, if I see those little tick marks, I know that those sections are equivalent. Now that section that's equivalent only goes from A to F, and from D to E. So right now, I have, this is the reflexive property. Then I also know that AF, that line segment, is congruent to DE, because that was actually given to us in the picture. And one of the things you need to know when we have pictures of things, we can't assume, even though it looks like things are equivalent, we cannot assume that they're equivalent unless it tells us that. In this case, it does tell us that it was given to us. So we know that AF is congruent to DE, so that means this section here and this section here are equal, and I'm going to add another section to each of those. It happens to be equal. So if I add this section to this section, and then an equal section to an equal section, then I know that we've got two things that are congruent. So we can say that AF plus FE equals, oops, that's supposed to be equals, AE, and I know that DE plus EF equals DF, and there's a rule that we just learned, which is that line segment rule for both of those. Okay. And the addition of line segments, right, or subtraction. So, if that's the case, if we add equal things to equal things, then we can say that AE is congruent to DF. And basically, the reason for that is when we add equal things plus equal, if you have equal things and you add equal things, you get equal things. Okay? So, we just basically proved, it didn't ask us to prove, but it's asked us which postulates we're going to use, and we used the reflexive property. We used that line segment, additional line segment property, and then we used another thing that we haven't learned about, that we actually learned before. It makes sense. If we had equal things to equal things, then things are going to be equal. We didn't learn it this week, but we've learned it, and we've learned it many times in the past. Okay? So, but what we're going to, basically what you saw is that we're starting to do something called proofs in geometry. And what we're doing is we're proving different things. So here, even though we were asked to do that, we basically proved that AE is congruent to DF. Using these steps, we're justifying and giving our reasoning why AE and DF are actually congruent. And that's basically what proofs are, is showing your reasoning, your thinking in your head, and the steps that would explain to somebody why this statement is true, or this statement is true. So, when we're doing proofs, you're always given some information and asked to prove something. So you're given information, and if you go back here, we were given that AF and DE were congruent. Then we were asked to prove something. And if we go back again, we would have been asked to prove that AE and DF were congruent. It's not the exact question they asked, but that if we were asked to prove something, that would be what they were asking us to prove. Also, there's a picture. If there's not a picture there, then you need to sketch the picture. So oops, wrong direction. They gave us a picture here that I actually covered up so we could see the part we needed to focus on. Because even though there's triangles there, we didn't need to focus on the rest of the triangles. We only needed to focus on the bottom part of this. So that's why I covered that, to help us kind of focus on that section and help it make sense and see just doing other things. That's kind of the tricky part about doing proofs, is being able to see the parts that we need to talk about and think about in order to get us to where we to showing and justifying why the part we're supposed to prove is true. So oftentimes you need a picture. Sometimes it's provided, sometimes it's not, and you may need to sketch that picture. Okay? And then it says set up two columns. So the first column labeled statement, the second column labeled reason. And you're going to see that right here. So we're going to try one of these proofs. And so we've got some information that's given. It says triangle ABC, triangle ADC, and quadrilateral ABCD. So we know that you can have C dot ABC, D. So A, B, C, D, looking at the whole thing, is a quadrilateral. But you can also see that there is a triangle inside, A, B, C. And notice the next one they said ADC, because you can see then that matches the order of the one up above. We know from this information that line segment AB is congruent to line segment AD, line segment BC is congruent to line segment DC, and angle B is congruent to angle D. Now there's more information here, but let's just deal with this part right here. So the first thing you really need to do is read through everything and just mark information down on your picture of what you know is true. So we'll get to this section, part in a second, where AC bisects the angles. So let's just deal with this part. And we're going to just cross off as we use it. So it says line segment AB is congruent to line segment AD. So I'm just going to put a little tick mark there for each of those, so that I can remember that those two are, and when I look at the picture, that those two are congruent. So we've used that information. Then it says BC is congruent to DC. So now I'm going to put two tick marks here because that's a different length than the other two. And so we've used that information. Just a little check mark there. Now it says angle B is congruent to angle D. So I'm going to put a little line here, a little arc here, that those two angles are congruent. Okay? So I'm going to put a little check mark there, so I'm going to use that. Now, the next thing it says is AC bisects angle BAD and angle BCD. So if something bisects something, remember that bisect means it's cutting it into two equal pieces. So basically, this line right here is cutting the entire angle BAD into two equal spots. So this side here and this side here are exactly the same. And that's something that was given to us also. So let's mark that. And it says that it also bisects angle BCD. So there's BCD. So I know there C, remember C is in the middle, so C is where your vertex is for your angle. And if it bisects the angle BCD, that means that this side, this angle here, and this side angle here are exactly equal. So I'm going to mark this here. I'm going to do a little different mark here so I'm going to put a little line through that single line, and that's okay to mark it that way also. It's congruent. So we've got a bunch of things that are congruent. Now, the thing it's asking us to do, it says prove triangle ABC is congruent to angle ADC. So if we've got two triangles in there, triangles are polygons, and so that makes me think I need to go back to my polygon congruent. So I'm going to go back here. And it says two polygons are congruent if and only if all pairs of corresponding angles are congruent and all pairs of corresponding sides are congruent. So in order to say those two triangles are congruent, we have to have all the corresponding pairs of corresponding angles and all the pairs of corresponding sides being congruent, just like we did in the picture there. So let's go back. So that right now, I've got one pair of corresponding sides congruent and another pair of corresponding sides congruent. So in order to prove this, we've got to make statements that show all three sides are congruent and all three angles are congruent. So let's write that out. Right now we know that, let's just worry about the sides first. We know that AB is congruent to AD. That's information that we know. We also know that BC is congruent to DC. So we have two sets of sides that are congruent, and those were given to us. The reason that we can put there is that information was given to us. But we still need our third side. So where is our third side? Well, our third side happens to be here. And guess what? Both triangles share that third side. And we learned about it there, postulate and those types of things that helps us know something about share if things share a side. So let's go back and look at what that might have been. Oh, there it is. Okay, we learned about the reflexive property, and remember that said any side is congruent to itself. So remember here they shared the side, so we wrote that BD is congruent to DB, and you could write BD is congruent to BD also. And that's because of the reflexive property. So I can have a reason for saying, I'm going to write down this that I want AC, this is going to be a new section, I want AC congruent to AC. I can't just put that down without putting a reason or a justification, as you can see on the table. So my reason that I can write that down is the reflexive property. So I'm going to write reflexive. Okay. So now we have all three sides congruent, which is what we need to prove that any polygon is congruent. But we can't just stop there. We have to also prove that all our angles are congruent. Well, let's start with the first part here. The first part right here said angle B is congruent to angle D. So we can actually write that down. Angle B is congruent to angle D. And again, that was something you can see right here. It says that was given to us. So we can write right over here that was a given. But now we need the other two angles to be congruent. And this statement right here does not tell us directly that those two angles were congruent. It doesn't say angle BAC is congruent to angle DAC. It doesn't say that. What it says is AC bisects angle BAD and angle BCD. But we need those two angles to be congruent in order to show that our polygons are congruent. But we did have information that helped us know that. So let's write down what's congruent right now. So angle BAC is congruent to angle DAC, because we did mark it as that. But what was the reason that we could mark it that way? The reason was because we said we had something that bisects. So we have our, going back to a couple days ago, we have our angle, I'm just going to use the symbol for angle bisector postulate or theorem, I can't remember which one it is, but the angle bisector piece of that. Because if he says bisect, we know it cuts it into two equal pieces. We also know that then, because it says not only is BAD bisected, but it says BCD is bisected, so angle BCD is bisected, so that we could write the angle BCA is congruent to angle DCA. And it's for the same reason, so I'm putting it in the same box. Okay? And so once I've got that, I have all three sides congruent, all three angles congruent. So I can actually write now that triangle ABC is congruent to triangle ABC. And that would be because of our polygon congruence postulate. Okay, so there's a proof of that. And it gives you an idea of how we have to do proofs. First of all, we had to look at what we were trying to get to and think in our heads, what is it we need to have in order to be able to show that those two triangles are congruent. And we looked back and we said, okay, well, we know from our polygon congruence theorem that we're going to need three sides and three angles congruent, three sets of sides and three sets of angles that are congruent. And the way they wrote that is three sets of corresponding sides and three sets of corresponding angles congruent. And then if we have that, then we can say that those two triangles are congruent. And so we needed to see if we could find that information so that we could say those two triangles are congruent. And indeed we did, because some of it was given to us and the rest of it we could see in the picture. And there was reasons for what was not given to us. We had to put a reason down for being able to say that and state that. Okay, such as the reflexive property or angle bisector piece. Okay, so let's go to the next thing, because it gets a little bit tedious when we're proving two triangles congruent. We have to prove every single side and every single angle congruent, and there's actually ways to do it without having to do every single side and every single angle. So when we're proving two triangles congruent, right now, all we know is that you have to have all three sets of corresponding sides and all three sets of corresponding angles that are congruent. But there are other postulates that do allow us to prove triangles congruent with less information, but it still deals with angles and sides. Okay, so the first one that we have here is something called side, side, side. If the sides of one triangle are congruent to the sides of another triangle, then the two triangles are congruent. So basically, if I have these two sides congruent, these two sides congruent, and these two sides congruent, then we know the two triangles are congruent. And there are some things that go along with that that we haven't learned yet that explain why that works. It has to do with angles, with the angles and the sides kind of being connected in a way, because of the angles and the rays and so on. So, but well, we're not there yet, and so we're just going to hold on to that and just let you know that if I have three sides that are congruent, I can say that the two triangles are congruent. So basically back here, once we had this given statement and this piece right here, we could have stopped there and said that we do have two triangles that are congruent based on what we just saw. So again, our side, side, side congruent postulate. All right, so now we have another one. That next one is called side angle side. And it says if two sides and the included angle in one triangle are congruent, then two sides and the included angle in another two sides and the included angle in another triangle, then the two triangles are congruent. Now notice they used a special word here. It says the included angle. So if we look at the picture, notice that the angles that are congruent are between the two sides that are congruent. So it's side, then angle, then side. The side and the angle has to be between that side and the next side. So side, angle, side. Okay? Because we went around the triangle, we go side, angle, side, angle, side, angle, side. Okay? So it has to be, this angle has to be between the two sides that are, the two sets of sides that are going to be congruent. So we got side, angle, side. We usually write that as side, angle, side. Remember, and notice in the first one, it said side, 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 so we write S, S, S. And this one's SAS for side, angle, side. All right, the last one that we have right now is angle, side, angle, congruence postulate. So this says down here, if two angles and the included side in one triangle are congruent to two angles in the included side in another triangle, then the two triangles are congruent. So again, they say the included side. That means that the side has to be between the two angles that correspond to the other two angles. So this angle, then the side right there, and then the angle that follows it. Angle, side, angle. So it's included between the two angles. That's really important. That the side can't be an angle here, and a side over here, because that is not an included side. It has to be included between those two angles. So keeping that in mind, let's look at this. It says, are the two triangles congruent? And it says, determine whether triangle ABD is congruent to angle CBD. And if they are congruent, why? So if I'm looking at this, I see, oh, this has got two sides that are congruent and two sides that are congruent. And there's the third side right there. And I notice that the two triangles share that third side. So that tells me that BD is congruent to BD, and we know we have a special postulate for that, and it's the reflexive property. Actually, it's a property. Okay. Okay, so we've got the reflexive property there. So we can mark that 1, 2, 3. And since I have I've got one pair of sides that are congruent, two pairs of sides that are congruent, and a third pair of sides that are congruent, I can say yes, these two triangles are congruent based on side, 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 which we just learned. How about this one? This one has a side that's the same. The next thing, as I go around the triangle, I see an angle that's the same, and then I see a side that's the same. And based on our theorems before, those two would be congruent because we have a side, then an included angle, and a side that are congruent. And so those two angles are congruent because it's side, angle, side. How about here? Let's take a peek at this. Now let's look. Even though this triangle and this triangle are turned a little bit and flipped around and so on, they still have things that are corresponding to each other. So this angle matches this angle. The next thing I see is this side, and it matches this side, and I see this angle, it matches this angle, and the side is in between. It's included between the two angles. So these two triangles would be congruent based on angle, side, angle. And actually, having it, that makes some sense based on several things that we've talked about so far. But we'll hold on to those thinking until we go a little further. All right, so if we're going to prove two triangles congruent, it says T is the midpoint of QR and QS is congruent to RS. So that's some given information. And they start us out with QS is congruent to RS, and since that's up here in the given information, our reason for writing that down is given, because it was given to us. So we can't write anything down in the statement column unless we have a reason to go with it. Okay? So let's mark RS and QS as congruent. So we said RS is congruent to SR, or QS, either way. RS is congruent to QS. And that was because it was given. And then it gives us another piece of information here. It says T is the midpoint of QR. And if something's a midpoint, that means it's splitting that line in half. It's midway. So this part right here is the same length as this part right here, because that point right there at T is splitting QR in half. So what I can say is that QT is congruent to TR. And the reason is because of midpoint. Midpoint splits that line in half. That's what that means. Something that's halfway on the line. So this right here is congruent to this right here. So right now we've got two sides that are congruent. So let's go back and look at what we've got. That we just talked about. We talked about angle, side, angle. We talked about side, angle, side. And we talked about side, side, side. And as we look at that, right now we've got two sides that are congruent. Or two pairs of sides that are congruent, corresponding sides. So right now, I either need to be able to show that there are two angles that are congruent, or that there are that this angle right here between those two sides is congruent, or there's a third side that's congruent. And so right now, we haven't talked about how to make just enough about the angle piece of this. So it makes sense to me that we're probably going to be looking for a third side, because they didn't give us any angle information up here, and we didn't have any theorems that go along, or postulates or anything like that to go along with that. So I'm noticing that the two triangles are sharing this side right here. And if that's the case, then TS is going to be, since they share the side, that side is going to be a corresponding side that is congruent. So I can write TS is congruent to TS because of the reflexive, and the reason is the reflexive property. When something is equal to itself, it's always the reflexive property. Okay. And since we have one, two, three pairs of corresponding sides that are congruent, I can actually say now that these two triangles are actually congruent based on our little theorem that we got before, which was side, side, side. Or actually postulate, sorry. Okay, so we showed that we were trying to get to showing that these two triangles are congruent, and we showed that they were congruent because we found three pairs of corresponding sides that are congruent. And if that's the case, then we know that we have two triangles that are congruent. How about this one? Let's look at this one. Let's prove two triangles congruent again. So here's our picture. It says in triangle PQR, line QM, which is from here to here, bisects angle PQR, so it bisects PQR, so that larger angle there, and line QM is perpendicular to line PR. And you can see it's marked there as a right angle. If it's perpendicular, there's a right angle. And so there's a couple of things that we're going to kind of come across. And it says, why is triangle PMQ congruent to RMQ? So why is RMQ congruent to PMQ? So we're going to again go through proving these two as congruent, because that's what it's asking us to do, but it gave us some information here. So let's think about that. It says QM bisects angle PQR. So if it bisects an angle, it means it cuts it into two equal pieces. So that means that this angle right here is congruent to this angle right here. So we can write, usually we start with something that's given, and so our given would be QM bisects angle PQR. And because it bisects angle PQR, we can say that angle RQM is congruent to angle PQM, and that's because of the angle bisector. Since, although we know that that's going to be true because of this statement here, it's not actually written or stated up here, so I have to actually write it and state it down here. Okay, so we know that those two angles are congruent. Okay, so that tells me I'm either going to need two sides now or two angles that are congruent. And so let's look at the next piece of information we have. This is angle, or length, side QM right here is perpendicular to PR, which is right here. So that tells me something about another angle. Okay, so if this is 90 degrees, then that angle right there is also 90 degrees because it's a straight line for PR. So we can write angle RMQ is congruent to PMQ. Oops, sorry, missed a step here. We know that, let's try this again, we know that QM is perpendicular to PR. And that was given. Can't forget to write down the given part. And now we can say, because we can't do that the next part until we know what the information is given. So angle QMP is congruent to angle QMR because of lines being perpendicular. When lines are perpendicular, they form right angles. and they form right angles on both sides of that line, which are perpendicular too. So right now, I see two sets of angles that are congruent. So let's look at the side in between those two sets of angles. So I've got angles here and angles here. So let's look at this line right here. Well, that line is shared by both of the triangles. So I can actually say QM is congruent to QM, and that's reflexive property. And now I'm going back here, I'm going to mark it there. I'm going back to look again, and I see that I have an angle and an inclusive side, and an angle and that side is included between the two angles. So I can go back, and if I look back, I see that I can now say that I've got two triangles that are congruent. Triangle PMQ is congruent to triangle RMQ. And that's because of angle, side, angle. Okay. All right. And so we've got a little bit of an idea of what we're doing with proofs. Just to kind of review, remember proofs that you're given some information. Like we did, like we were given here. And you need to use that information to show somebody else why the proof part is true. It says you're going to, so they're given information in the proof part. You use this information to show that this is a true statement. And every time you write a statement here, which includes your given information, you have to write a reason. If the information is actually stated up here, then you just write given. But if it's something you have to reason through based on the picture, like we did the angle bisector, it said it bisects it, but this didn't tell me that those two angles were equivalent. It just was a start to that thinking. So I had to write down that those two angles were actually equivalent, and the reason is because of the angle bisectors. Then we had to go to the next given piece, and then we had to write the information that we knew because of that given information, and we had to give the reasoning for it because lines are perpendicular. Perpendicular lines form right angles. And then we had the next piece that wasn't given, but we could see we needed that side to be, the sides to be equal there. We needed angle, side, angle. And so it's the same side, and so we wrote that down and wrote the reason because this was not given information, but we could see it from the picture, so we had to give the reasoning. And then the same thing with the last one, we had to give the reasoning why that works. So we had either, we were looking for either side, 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 angle, side, angle, or side, angle, side, and we found out we needed angle, side, angle to prove those two triangles congruent. So that's proofs, and that's some information that we learned about how to prove two triangles congruent. And with that, we are done for the day, and hopefully you'll enjoy the rest of your day.